Grade 8 Mathematics classroom. Today we are going to discuss about the first lesson in Grade 8 Mathematics, that is number patterns. Right, before moving to the lesson, I thought of telling you what you are going to learn after studying this lesson. After studying this lesson, you will be able to identify the nth term of a given number pattern and find any term of a number pattern when the nth term is given. Right. Now, what is this number pattern? First of all, we have to have an idea what a number pattern is. Then we have to have an idea what the terms of the number pattern is. So, first of all, we will see what a number pattern is. I am going to consider about the odd numbers written from 3 to 11 in ascending order. So, what are the odd numbers from 3 to 11? Just say 3, 5, 7, 9 and 11. So, we can write it in ascending order as 3, 5, 7, 9 and 11. Right. Now, we will have a look at this one. So, when we are writing a sequence of numbers in a certain order, it may be the ascending order or the descending order. So, when numbers are written in a certain order according to a specific method or specific rule, starting from a certain number, that is called a number pattern. So, we should have a specific order, that may be the ascending order or the descending order, and we should write the number sequence according to a specific method or a rule. Right. Now, previously we have written a number pattern, therefore. Why? There was a specific order. We have written it in ascending order. Isn't that so? 3, 5, 7, 9 and 11. That is in the ascending order. What is the rule there? All the numbers are odd numbers. And we have to consider about this one as well. Every number in a given number pattern is called a term of the number pattern. Right. Once again, we will think about the numbers we have considered previously. The odd number pattern from 3 to 11. We had 3, 5, 7, 9 and 11. Therefore, we can say 3, 5, 7, 9 and 11 are terms of this number pattern. Right. We will talk about the terms furthermore. Now, have a look at this number pattern. Here, I have mentioned the number pattern of the multiples of 4 written in ascending order. So, what should be written there? What are the terms? 4, 8, 12, 16, 20 and we can write so many terms there because there is no end point specifically given. Isn't that so? Therefore, we will first of all identify about the terms. So, number 4 comes first. Therefore, we can name it as the first term of the number pattern. Then it comes number 8. That is the second term of the number pattern. Then number 12. So, we can consider it as the third term of the number pattern. Then 16 is the fourth term of the number pattern and 20 is the fifth term. As I have mentioned before, we can write any more terms there because they have not specifically given the end point of this number pattern. Now, we have discussed about two types of number patterns. First one was the number pattern where we knew the exact number of terms. That was the odd number pattern starting from 3 to 11. Isn't that so? There we had 3, 5, 7, 9 and 11. That means we had only 5 terms there. Then we have discussed about the number pattern of multiples of 4 starting from 4 and written in ascending order. There actually we didn't know the number of terms because they have not mentioned the end point of that number pattern, right? Therefore, when we consider about this feature, we can separate number patterns into two types. First one is the finite number patterns. Finite number patterns in sense, if we exactly know the number of terms in that number pattern, or else we can say if the number of terms in the number pattern are finite, we can name it as finite number pattern. So, we will go through the definition of the finite number patterns. Number patterns in which the number of terms is finite are called finite number patterns. So, we can move on to an example, the same example we have discussed previously. This is the odd number pattern from 3 to 11. So, we exactly know we have got only 5 terms there. What are the 5 terms? 3, 5, 7, 9 and 11. Right. So, if the number of terms is finite, we have named it as finite number pattern. So, what about the other type? If the number of terms is not finite, then we can name the number pattern as infinite number pattern. As we have discussed previously, can you remember the number pattern of multiples of 4 starting from 4 and written in ascending order? There we knew the starting point, but we could write any number of terms in that number pattern because there was no end point. Isn't that so? Therefore, we can move on to the definition of the infinite number patterns as the number patterns in which the number of terms is not finite. If the number of terms is not finite, or if you can mention any number of terms in a number pattern, we can call that number pattern as an infinite number pattern. So, we will move on to another example there. 5, 10, 15, 20, 25 and so on. What is this number pattern? Yes, it is the number pattern of multiples of 5 starting from 5 and written in ascending order. Right, here also we know the first term, second term, third term, but after that we can write up to any number of terms because this is an infinite number pattern. So, there is a special feature that we can identify an infinite number pattern. How to identify an infinite number pattern? If the number pattern is finite, when writing the terms, we can obviously write from the first term to the last term. But if the number pattern is infinite, we can't mention all the terms when listing down the terms. Therefore, we can mention up to 4 or 5 terms. After that, we have to put a comma and put 3 dots afterwards. Why is that? That represents that the terms can be continued because it is an infinite number pattern. Right. By now, we have discussed about the number patterns, then the terms of the number patterns, finite number patterns and infinite number patterns. Now, we are going to discuss about the general term of the number pattern. What is this general term? We have discussed about the terms, first term, second term, third term. We have discussed about those terms. What is this general term? We will see. Have a look at this example. In the number pattern 2, 4, 6, 8 and continuous, we can list down the terms there. First term, second term, first term is 2, second term is 4, third term is 6, fourth term is 8. Likewise, we can list down the terms. Now, what is this number pattern? This is the number pattern of multiples of 2 starting from 2 and written in ascending order, or else we can name this as the even number pattern starting from 2 and written in ascending order. Right. But if I ask, what is the 105th term of this number pattern? Is it easy to provide the answer quickly? No, isn't that so? It's a little difficult. Therefore, we are going to introduce the nth term of the number pattern. What is this nth term? Nth term represents an algebraic expression that represents the general term of the number pattern. So, we will see how to find the nth term or how to get the general term of a number pattern. Here I have provided a table for you to observe a special feature. We will see. First of all, I have written the terms. First term is 2. How can I obtain 2? When we observe this number pattern, we have to have a common pattern to obtain the terms. What is that? We will see. First term can be obtained by multiplying the number of the term by 2. Here the number of the term is 1. When we multiply it by 2, the answer is 2. Therefore, we got the value of the first term. So, we will check it for the second term as well. So, number of the term is 2 multiplied by 2. So, 2 multiplied by 2. Yes, we got the value of the second term correctly. Now, we will see for the third term. The number of the term is 3 multiplied by 2. That means 3 multiplied by 2 is 6. Yes, for the third term also we got the value of the term correctly. So, therefore, we will check for the 8th term now. Now, the number of the term is 8 multiplied by 2. 8 multiplied by 2 means 16. Once again, we got the value of the term correctly. Therefore, we are going to find an algebraic expression for the nth term of this number pattern. Once again, we will follow the same method. Number of the term n multiplied by 2. 2 multiplied by n can be considered as 2n. Therefore, we can say the nth term of this number pattern is 2n. That means the general term of the number pattern of multiples of 2 starting from 2 and written in ascending order is 2n. Right. Now, we have constructed a general term to the number pattern of multiples of 2 starting from 2 and written in ascending order. That is 2n. So, I am going to use the general term in few questions and we will see how we can use the general terms to get the answers for these questions quickly and correctly. Right. This is my first question. In the given number pattern, part 1, what is the 12th term? Part 2, what is the 104th term? Right. First of all, we have to see what the given number pattern is. We will have a look at the terms of it. 2, 4, 6, 8 and it continues and they have mentioned 2n as well. What is this? This is the even number pattern starting from 2 and written in ascending order. So, we will try to find the answer for the first one. What is the 12th term? Before finding the 12th term, we have to know what the general term is. So, here the general term is 2n. So, we need to find the 12th term. Therefore, instead of n, we have to substitute the value 12. Therefore, we can easily get the answer for the 12th term. That means value of the 12th term. Here n equals 12. Therefore, 12th term can be obtained by multiplying 12 by 2. The answer is 24. Then the second question. What is the 104th term? Once again, we have to know the general term, that is 2n. In this case, n is equals 104. Why? We need to find the value of the 104th term. Therefore, we can easily get the 104th term by substituting the value of n. Therefore, it becomes 2 multiplied by 104. So, the answer is 204. Right. We will move on to the third part of the question. Which term is 162? This time, they are not asking about the value of the 162nd term. They are not asking that. They are asking which term is 162. That means the value is 162, but they don't know the number of the term. They are asking us to find that. Therefore, we can say the general term is 2n. So, the value we know, therefore, we can construct a simple equation 2n equals 162. Right. Now, since it is a simple equation, by now you know how to simplify this simple equation. Simplifying an equation in sense, we have to have the unknown term in one side and we have to take all the other values to the other side. 2n means 2 multiplied by n. So, to get rid of the multiplication of n, we have to divide both sides by 2. Therefore, 2n divided by 2 equals 162 divided by 2. So, 2 to 2 cancel off in left hand side. Therefore, we can get the value of n as 162 divided by 2 is 81. Right. Now, we have got the value of the third question as well. Right. I have told you the general term of number pattern of the multiples of 2 starting from 2 and written in ascending order is 2n. Then what can you say? What is the general term of the number pattern of multiples of 3 starting from 3 and written in ascending order? We will see. We can use the same method to find its general term. So, we can observe the general term of the number pattern of the multiples of 3 starting from 3 and written in ascending order is 3n. Therefore, we will now consider about the general term of the number pattern of the multiples of 4 starting from 4 and written in ascending order. So, accordingly, we can get its general term as well. Therefore, the general term is 4n. Likewise, the general term of the number pattern of the multiples of 7 starting from 7 and written in ascending order is 7n. Likewise, we can find the general term of any number pattern when it is given as a multiple of a whole number. Right. So, we will move on to another question quickly. This is my second question. The general term of the number pattern of the multiples of 5 starting from 5 and written in ascending order is 5n. Here they have mentioned the general term as well. So, it is easy now. Part 1, what is the sixth term of this number pattern? Right. Here they have mentioned the general term. So, it is easy now. As we have discussed previously, when we substitute the value of n to the general term, we can easily find the value of the term. So, we can find the sixth term as the general term is 5n. We will substitute the value of n here, that means the number of the term, that is 6. Therefore, instead of n, I have put 6 there. So, 6 multiplied by 5 is 30. Therefore, the sixth term of this number pattern is 30. Right. Second question. What is the 15th term of this number pattern? Once again, we can easily find the 15th term as here the n is equals 15. So, the general term is 5n. We will substitute the value of n. Therefore, we can get 15 multiplied by 5. So, the 15th term of this number pattern is 75. Right. So, we will move on to the third part of the question now. Which term is 125? Right. As we have discussed previously, this time also they are not asking about the value of the 125th term. They are telling the value is 125. They want to know which term is it. Right. Therefore, once again the general term is 5n. So, we can construct a simple equation as 5n equals 125. Once again 5n means 5 multiplied by n. Therefore, to get rid of the multiplication of 5, we have to divide both sides by 5. Then it becomes 5n divided by 5 equals 125 divided by 5. Therefore, we can get the value for n as 25. That means 125 is the 25th term of this number pattern. Right. Then let's move on to the fourth part of the same question. Is 71 a term of this number pattern? What are the reasons for your answer? So, here inside the same question they are asking us about two things. First of all, we have to check whether 31 is a term of this number pattern or not. Then we have to provide reasons. Here providing reasons in sense you have to show the workings and we have to show whether 71 is a term of the number pattern or not. Right. Now, here the value is 71. If we are having value 71 in this number pattern, we should have constructed this equation, simple equation 5n equals 71. So, if 71 is a value, when we simplify this simple equation, we should get a positive integer or else a whole number as the answer for n. Why is that? N means the number of the term. Always the number of this term should be a positive integer or else a positive whole number. So, we will check, we will construct the equation 5n equals 71. Once again 5n means 5 multiplied by n. Therefore, to simplify this we have to divide both sides by 5. Therefore, it becomes 5n divided by 5 equals 71 divided by 5. So, here we can get an answer for n as 14 1 over 5. There the answer is not a positive integer. So, can we have a mixed number as the number of the term? No, obviously you should have a positive integer as the number of the term. Why? We count in positive integers or else the counting numbers. Therefore, here the answer is not a positive integer. Therefore, we can say 71 cannot be a term of this number pattern. Right, that is the end of that question. We will move on to another question. What is the general term of the number pattern of multiples of 3 which is more than 2 but less than 311? I will read it once again. What is the general term of the number pattern of multiples of 3 which is more than 2 but less than 311? Here they are asking about the general term of the number pattern of multiples of 3 and written in ascending order. By now you know how to get the general term, isn't that so? Therefore, the general term is 3n. Then they ask, if the least value of n is 1, find the greatest value that can be taken for n. Right, n means here the number of the terms. So, if the least value of the number of the terms is 1, therefore, they are asking about the greatest value for n. That means they are asking about the final term of this number pattern. Since they have mentioned this number pattern is in between 2 and 311, we can observe that it is a finite number pattern. So, how to find the final term of this number pattern? We will see. So, here if 311 is a term of this number pattern, we should have constructed an equation as 3n equals 311. Here we have taken 311 because they says the value is less than 311. So, obviously the value should be less than that, but we will just consider 311 as a value. We know that it is not a term of this number pattern, but we need to get the greatest term first. Therefore, to find the greatest term, we will construct this equation and then we will try to simplify it. The number of the term, the value for n which we can get here by simplifying this equation would help us to find the greatest term or the last term of this number pattern. Right. Now, here 3n equals 311. Once again 3n means 3 multiplied by n. Therefore, to simplify this, I need to have n alone in my left hand side. Therefore, I am dividing both sides by 3. Therefore, we can get a value for n as 103 2 over 3. Right. As I have mentioned before, 311 is not a term of this number pattern. It is not the value of a term, but this answer would help us to find the greatest term or the last term of this number pattern. Right. Since we can't have 103 2 over 3 terms, we can observe that the greatest term should be the 103rd term. So, we can say the highest value which can be taken by n is 103. Therefore, 103 is the final term of this number pattern. Right. Now, we have discussed about the general term of the number patterns of multiples of whole numbers and written in ascending order. Now, we are going to consider about the general term of the odd number pattern starting from 1 and written in ascending order. Right. Now, what are the terms there? The odd number pattern starting from 1 and written in ascending order, we can get 1, 3, 5, 7, 9, 11. Likewise, we can have any number of terms because I am talking about an infinite number pattern. Right. Once again, we are going to construct the general term. So, we will try to observe a pattern there. So, here have a look at this table that I have given. First term is 1. Therefore, 1 is going to be obtained like this. Have a look at this one. The first term of the multiples of 2 starting from 2 is 2. So, we got it by multiplying the number of terms by 2. Here, I am going to obtain the first term of the odd number pattern starting from 1 and written in ascending order by multiplying the number of terms by 2 and subtracting 1 from that. So, when we consider about the first term, the number of the term is 1 multiplied by 2 is 2 into 1, 2. Subtracting 1 from that means 2 minus 1, the answer is 1. Therefore, we got the value of the first term. So, we will use the same method for the second term as well. The number of the term is 2 multiplied by 2 means 2 multiplied by 2, 4. Subtracting 1 from that means 4 minus 1, that is 3. We got the value of the second term also correctly. So, we will check for the third term. The number of the term is 3 multiplied by 2 means 3 into 2, 6. Subtracting 1 from that means 6 minus 1 equals 5. We got the value of the third term also correctly using this method. So, we will check for the 8th term now. Now, the number of the term is 8 multiplied by 2 means 8 multiplied by 2, 16. Subtracting 1 from that means 16 minus 1 is 15. Right. According to this method, we are going to find the general term. That means an algebraic expression for the nth term. So, when we consider about the nth term, number of the term is n multiplied by 2 means 2n, subtracting 1 from that means 2n minus 1. Therefore, we can say the general term of the odd number pattern starting from 1 and written in ascending order is 2n minus 1. Right. Now, we know the general term of the odd number pattern as well. So, we will try to use this general term of odd number pattern starting from 1 and written in ascending order in few questions, and we will see whether it helps us to find the answers quickly. So, this is my first question. In the odd number pattern 1, 3, 5, 7 and continues starting from 1 and written in ascending order. First one, what is the general term? We have already obtained that is 2n minus 1. Second one, they are asking us to find the 11th term. As I have mentioned before, using the general term, it is really easy to find the value of a term. The only thing we have to do is we have to substitute the value of n. Now, here n is equals 11. Therefore, we can substitute the value of n. So, it becomes 2 multiplied by 11 minus 1. So, 2 multiplied by 11 is 22. 22 minus 1 is 21. So, the 11th term of this number pattern is 21. Then the third one. What is the 34th term? Once again, we can find it quickly using the general term. We will substitute the value of n. Here the n is equals 34. So, we can get the equation as twice of 34 minus 1. So, 2 into 34 means 68. 68 minus 1 is 67. So, 67 is the value of the 34th term of this number pattern. Right. We will move on to the fourth question as well. Which term is 127? Here they are not, once again they are not asking about the 127th term. They are saying which term is 127. That means the value of the term is 127. They need to know the number of the term. So, once again we can construct a simple equation using the general term. Therefore, once again we can construct a simple equation using the general term. So, it becomes 2n minus 1 is equals to 127. Once again it is a simple equation. By now you know how to simplify a simple equation. Simplifying a simple equation in sense, we have to have the unknown term in one side and we have to move all the other values to the other side. Therefore, in my left hand side I have got 2 multiplied by n minus 1. So, first of all we have to get rid of this minus 1. Therefore, we have to add 1 to both sides. So, 2n minus 1 plus 1 equals 127 plus 1. So, in my left hand side now I have 2n in my right hand side, now I have 127 plus 1 means 128. Right. Now, only the multiplication is there in my left hand side. So, 2n means 2 multiplied by n. So, to get rid of the multiplication of 2, we have to divide both sides by 2. Therefore, we can get the value of n as 64. That means 127 is the 64th term of this number pattern. Right. Then we will move on to the fifth part of the question. Part 5. Which term is the greatest odd number less than 150? Right. Now, they are asking about the number of the term of the greatest odd number less than 150. So, first of all, we have to know what the greatest odd number less than 150. We all know that 150 is an even number. 1 less than that should be the greatest odd number less than 150. Therefore, 1 less than that means 149. Right. Now, therefore, they are asking about the number of the term of 149. So, once again we can construct a simple equation using the general term. So, 2n minus 1 equals 149. Once again we have to first of all get rid of minus 1. Therefore, I have add 1 for both sides. So, it becomes 2n minus 1 plus 1 equals 149 plus 1. So, in my left hand side I have got 2n only, in my right hand side I have got 150 only. Right. Now, to find the value of n, I have divided both sides by 2. So, 2n divided by 2, it becomes n. 150 divided by 2, it becomes 75. That means 149 is the 75th term of this number pattern. Right. By now, from the beginning, we have discussed about the number patterns, then the terms of the number patterns, then we have moved on to the finite number patterns, infinite number patterns, then we have discussed about the general term of the number patterns of multiples of whole numbers. Right. Now, we are going to discuss about the general term of the square number pattern. Right. You have already learned what square numbers are. Right. Have a look at this one. The first, now I have represented these square numbers using dots as well. Can you remember when you are in grade 6, you have represented square numbers using dots, isn't that so? So, the first term of the square number pattern can be obtained by 1 multiplied by 1 is 1 square. There are how to get 1 multiplied by 1? Here we have got 1 row and 1 column in this square of the first term. So, second term, when we consider about the figure, we have got 2 rows and 2 columns. So, we can get the value of it 2 multiplied by 2, that means square root of 2. Third term, there are 3 columns and 3 rows. Therefore, it becomes 3 multiplied by 3, 3 squared. Likewise, fourth term, fifth term, sixth term, up to any number of terms, you can obtain the values by multiplying the number of rows and columns of the picture representation. Right. Now, we will have a look at the values of those. So, the first term, as I have mentioned before, 1 multiplied by 1, that is 1 squared. That means the value is 1. The value of the first term is 1. Likewise, the value of the second term can be obtained by multiplying 2 by 2, that is 2 squared. So, that is equals to 2. Likewise, the third term, 3 multiplied by 3, that is 3 squared, that means 9. Likewise, we will have a look at the 10th term. We can get the 10th term by multiplying the number of term by itself. Now, the 10th term, number of the term is 10. So, 10 multiplied by 10, that is 10 squared equals 100. According to this pattern, we can get the nth term or the general term. So, here number of term multiplied by the number of term. So, when we consider about the nth term, n multiplied by n, that is equals to n squared. Therefore, we can say the general term of the pattern of the square numbers starting from 1 and written in ascending order is n squared. Right. Now, we know the general term of the square number pattern starting from 1 and written in ascending order. Then we are going to talk about the general term of the triangular number pattern. Right. We have learnt about triangular numbers in previous grades as well, isn't that so? Now, how to get the first term of it? First term, you have got 1 dot. I have mentioned the picture representation of the triangular numbers as well. When we consider about the first term, we have got only 1 dot. That means the value of the first term is 1. Second term, you can get 1 plus 2, so the value is 3. Likewise, you can get the value of the term third term by adding 1 plus 2 plus 3, the sum is 6, therefore, the value of the third term is 6. So, when we consider about the fourth term, that is 1 plus 2 plus 3 plus 4, so the sum is equals to 10, that means the value of the fourth term is 10. Therefore, have a look at this. Now, using this pattern, using the previous pattern, it is not easy to construct a general term. Therefore, I am going to double the triangular numbers or the value of the terms of the triangular numbers and try to construct a general term for this triangular number pattern. We know that for the first term, you got only 1 dot. Now, I am going to join 2 such values together. Right. Here, in each and every term, I have joined 2 such values together. That means, I have doubled the amount. Right. For the first term, I should have only 1 triangle, but here I have joined 2 together. So, when we join 2 triangles together, we will consider about the number of rows and number of columns now. So, look at the first one. There is only 1 row, but 2 columns. Second one, we have got 2 rows and 3 columns. Third one, we have got 3 rows and 4 columns. Fourth one, we have got 4 rows and 5 columns. When you double it, you can observe the number of rows is equals to the number of the term. Number of the columns is always equals to 1 more than the number of the terms. So, by multiplying these or by counting the dots of these, always we get the twice of or as the double of the value of a term of the triangular number pattern. Therefore, I am going to use that method, but as I have mentioned before, we will get the value doubled of it. Therefore, I have divided the value by 2. So, previously you got in the first one 1 row, 2 columns. So, I am going to multiply the values number of rows and number of columns together. 1 multiplied by 2. By multiplying it, I will get the value of 2 triangles. I want the value of 1 triangle, therefore, I am going to divide it by 2. We consider about the second one. The number of rows is 2, number of columns is 3. By multiplying the number of rows and columns, you will get the value of 2 such triangles, but I want the value of 1 such triangle, therefore, I am dividing the value by 2. So, have a look at this table once again. So, 1 multiplied by 2 divided by 2, then I can get the value of the first term of the triangular number pattern. Value of the second term, we will get 2 multiplied by 3 divided by 2. You got the value as 3, that is the value of the second term of the triangular number pattern. Likewise, third term can be obtained by multiplying 3 into 4 divided by 2, that is 6, that is the value of the third term. So, when we consider about the fourth term, we can obtain the value by multiplying 4 by 5 divided by 2. So, the value is 10, that is the value of the fourth term of the number pattern. Then likewise, the 10th term can be obtained by multiplying 10 with 11 divided by 2. So, 10 multiplied by 11 means 110, divided by 2 is 55. So, according to the same method, we can construct an algebraic expression for the nth term. So, nth term can be obtained by multiplying the number of the term, that means n, with the number of the term plus 1, that means n plus 1 divided by 2. Therefore, we can construct the general term of the triangular number pattern starting from 1 and written in ascending order as n into n plus 1 divided by 2. Right. Now, I am going to move on to some questions which are there in your textbook. So, quickly take out your textbook. This is the fifth question of exercise 1.4, that is there in page number 11. So, quickly take out your textbooks and read the question before me. Right. Before providing the answer for the question, we have to have a look at this one. Just have a look. Now, here it is about triangular numbers. So, we got the general term of the triangular number pattern starting from 1 and written in ascending order is n into n plus 1 divided by 2. It can be written without mentioning the multiplication sign. Right. Now, we know the general term of the triangular number pattern. So, now we will move on to the question. Find the total number of triangles in each of the following figures. Right. Now, we have got 4 figures. We can see some triangles there. So, we will count the number of triangles present. In part 1, we can see only 1 triangle. In part 2, we can see 2 small triangles and 1 big triangle. Therefore, altogether it becomes 1 plus 2, 3. Third one, we can see 3 small triangles, little big triangles and 1 bigger triangle. Therefore, altogether 1 plus 2 plus 3, there are 6 triangles. When you have a look at the fourth one, what can you say? There are 1 plus 2 plus 3 plus 4 number of triangles. That means you have got 10 triangles. Right. Now, I have put some dots after that also because I have understand what this pattern is. This is the triangular number pattern starting from 1 and written in ascending order. Right. Now, have a look at this one. The pattern of the total number of triangles in the figures in the given order is identical to the pattern of the triangular numbers starting from 1 and written in ascending order. Now, that is what we have already mentioned. Find the total number of triangles in the 8th figure that is drawn according to this pattern. Right. If we are going to draw triangles according to this pattern, they are asking about the number of triangles in the 8th figure. Right. Now, we have identified the values represents the triangular number pattern starting from 1 and written in ascending order. That means, we can relate the question like this. They are asking about the value of the 8th term of this number pattern. Right. Now, we already know the general term of the triangular number pattern, that is n into n plus 1 divided by 2. Right. Now, using this general term, I am going to find the 8th term. Right. Now, 8th term can be taken by n into n plus 1 divided by 2. I am going to substitute the value of n. So, here n equals 8, therefore, it becomes 8 into 8 plus 1 divided by 2. When you simplify it, 8 into 8 plus 1 means 9, 8 into 9 means 72, 72 divided by 2 means 36. That means the value of the 8th term is 36. Right. Now, I am going to have a look at the first question in your miscellaneous exercise of Unit 1. That is there in page number 12. Quickly turn to that page, please. Now, the question. In the pattern of the odd numbers starting from 1, commencing from the first term, if the first 2 terms, then the first 3 terms, then the first 4 terms are added and continued accordingly, a special type of number is obtained. Part 1. What is the special name given to these numbers? So, first of all, we will roughly write down what they are telling. Here, first term, then the first 2 terms, then the sum of first 3 terms, then the sum of first 4 terms likewise. Now, the first term is 1. 1 can be written as 1 squared as well. 1 squared is also equals to 1. So, sum of the first 2 terms, 1 plus 3, that is equals to 4. So, 4 I can write it as 2 squared. Next one, 1 plus 3 plus 5, that is equals to 9. So, 9 can be written as 3 squared. Likewise, here when we consider about these answers, we can observe it's another number pattern. What is this? Here the answers represents the square numbers. Right. Part 2. Find the number that is obtained if 15 of these terms are added in order starting from the first term. Right. Now, 15 of these terms are going to be added. Right. Once again, I will have the sketch. Now, they are asking about the sum of the 15 of the terms. Right. Now, we have previously observed that the answer of these additions is equals to the square number pattern. Therefore, they are asking about the 15th term of the square number pattern. Therefore, we can easily get the answer for this question by finding the 15th term. We know that the general term of the square number pattern is n squared. So, we will substitute the value of n. Here n equals 15. So, we can get the value by multiply 15 by 15, that is 225. Right. Now, that is the final question that I have to discuss today. So, before winding up the lesson, I am going to recall the things that we have learned today. That means, I am going to summarize the lesson. First, we have learned what a number pattern is, then what the terms of the number patterns are. Then we have discussed about the nth term of the number pattern, that means the general term of the number pattern. Finally, we have discussed how to obtain the values of the terms using the general term of number patterns. Under that, we have discussed about the number pattern of multiples of a whole number, then the number patterns of odd numbers, then the number patterns of square numbers, finally the number patterns of triangular numbers. Right. Now, it is your time to do the homework. That is, you have to complete the exercises given in your textbook. So, that is it for today. So, if you have missed the lesson, or else if you want to go through the lesson once again, you can watch the lesson through the YouTube channel channel NIE. So that's it for today. See you in another lesson. Take care.